Hello, everyone. I'm Javiera Laso. I'm from Chile, so welcome to this talk. Please raise your hand if you are a developer. I am. Now, please raise your hand if you had the opportunity to work in a legacy system at some point of your career. Yeah. So we know architecting applications is very, very hard. So Conway establishes that system designs are a true reflection of how an organization is structured. If an organization has a silo structure where each team is isolated from the rest, the architecture design will have the same fate. For example, a system that is dividing front-end, back-end, database administrators will have communication problems and couple of the context of the team. Of course, each team has their own priorities. Why should I put you in front of my priorities? We will always look forward to have the best architecture, but do we know what is our goal of it? Exists any silver bullet for architecture? There are several types of architecture which seek to solve different problems and vary in complexity. For example, in monoliths, we have layer architecture, modular architecture, microkernels. For distributed, we have microservices, service-oriented, event-oriented architecture. Among these types, there is no concept of the best architecture, since everything, and here I'm using my consultant skills, it depends on the context and the problem that we want to solve. But let's go deeper into a monolithic architecture, but also on a big ball of mud. A monolithic application, as everybody knows, or most of you know, it's described as a single-tier software application in which the user interface and data access code are combined into a single program from a single platform. We usually hope to have a monolith that can be escalated or at least understood by all the developers. If we zoom in this big ball of mud, we might be able to relate with our application. Because why do we have this big ball of mud? Maybe because we don't have tests, maybe because we had tech debt, or it's hard to deploy. We are in a legacy system. It's hard to escalate. The CI/CD process are not implemented. Our culture is very hard. The monitor is not working, and there is no boundaries in services. So in here, maybe we can relate with this very couple monolith. Now, what is our priority? Decoupling. So domain-driven design process, as we know, consists on a collection of patterns, principles, and practices that enable the team to focus on what is critical to the business success while building software that manage complexity in both the technical and the business space. So at the beginning, we might try to align, discover, talk with our experts. That could be business related, it could be our architects. Then we will decompose, we connect, we will talk about our business context, about everything that is involved, like even the manager, even the developer, or QA, or business analyst, everyone will talk. Then we will strategize and organize to finally define what are our roles and responsibilities, because we need to set the boundaries of our context. And as you see, at the end, we have code. Code is not the main part of this, it's one of them. We try to put everything together in practice, but conceptually what this means is that the bounded context, we can group functionality according to whether various functions we share in a single domain model. So let's remember that bounded contexts are not necessarily isolated from one another. As we can see here, we can have a product catalog context, a shipping context, a payment context, and more. But if we zoom in, we can see more than how can be shared. We can also think on duplicate code versus high coupling. We don't want to couple too much, so we will sacrifice some duplication of code sometimes. And also, this gives us the ability to evolve according to the context. A product is conceptually completely different according to its context. One from the shipping, it's different from the inventory. And now, okay, we talk about context, but how do we talk with the business? We need to put this maybe into code. We need to have an ubiquitous language, as we know. If we have or maintain a common language between business experts and technology experts, but it's more important to be able to transfer these concepts to the source code so that our software products reflects the concepts that are commonly spoken by the business. Let's also think about our architects, all domain experts. They need to have a common understanding too. We can have different experts, but all are looking for the best of the application and the business health. A quick way to start with this, it could be like have a wiki or Confluence with acronyms of the business. But how can we start talking with the business? Well, they can come to the conference, but also they can do some event storming. So this event storming is a workshop, as we know, to quickly find out what is happening in the domain of a software program. So it provides a structure to the business flows that arise, but the real value is the conversations involved, because we will have everybody there. The flow of events in the organization is discussed and flows in model in an easy-to-understand way, but you can build software system from the models or use the knowledge gained from these discussions to better understand and refine this business process. As we know, there is no silver bullet for this. It's always improving. So at the end, we might end up with something like we used to have like the thing in the right, the thing on the left, but you can understand what is happening. Even when the architecture is not perfect, we will have a common understanding. The traditional structure breaks the encapsulation, while the domain architecture reinforces. We can also make the reflection. Can you in the audience understand what is happening here? You understand more the right, more the left? Can you really see what we wanted to do with this? Now, how do we will apply this to our monolith? So there are different migration patterns that can be helpful. We can design how to start migrating using maybe this, where we will like move into monolith using an in-place refactor, right? Or maybe we will need a strangle-fit pattern. After our monolith is understandable, we can start focusing in parallel how to approach the DDD. If we need more help, we also have a value stream map where we can prioritize. We can decide how to start migrating this monolith, and we can focus in, for example, the plan, the developer experience, the lightweight domain modeling. Or maybe we need to start thinking about the pre-deployed test when we need to add maybe fitness function. Maybe we have tests. Maybe we need to encourage the whole organization to start doing this, because we know this migration is not going to be just developer-based. It's going to be a whole new organization thoughts about how we model, about how we like hold the application and go into production. It's not going to be me as a developer just pressing a button and going to production. It's going to be the whole business who had I talked before and who I modeled the context and everything. So they need to be involved. Also, we need to consider, for example, monitoring the 4 key metrics. But the most important part is to talk and map the changes that we want to make. If we don't have a plan, it's very hard for us to really understand what is happening. It could be better, always can be better, but we need to talk and show what is happening. There's a lot of refactoring resources that you might find everywhere, so I suggest you start looking on them and also like inviting them here. But how can we maintain the architecture over time? Because what I do today, it's very hard for me to remember tomorrow. I don't even remember what I have for breakfast. So how do we maintain this architecture? We may need to use C4 diagrams. This is kind of very simple. Maybe you saw a few, or maybe not. Maybe we usually go until C2, or maybe you don't know what is this. But there are 4 phases, where are the system context, the container diagram, the component diagram, and the code. So if we take it, for example, we have a bicycle. We have a big context of a bicycle, a biker. Then we go deeper. We try to see, oh, there's maybe a wheel. But what is the wheel made of? Oh, there's a molecular structure for the rubber. So we do need to, we can go deeper and deeper. We can explain our model, or that's our goal, to explain it in 5 minutes, an hour, 5 hours, or maybe a whole workshop about our processes. Now, we can try to also test our architecture, because that's the part that we like. We like to code and maintain this. We can use this ArcUnit, for example, framework. We will help us to avoid cycle level dependency, prevent architecture definition from drifting over time, and set architecture guidelines in the team. Also, there are automated tests with technical agreements on the team level. So we can put this on the pipeline and be aware that, okay, if I'm using layer architecture, I have some rules that I need to keep. Or if I need to not be dependent on packages, specials. We have this framework for different languages, and the main idea is the same. It's maintain our architecture over time. Also, is our documentation. The architecture decision records, or ADRs. Always happens to me that I go to a new project and I see the onboarding. The onboarding process says like, okay, you will have stand-ups, you will have retros, and you need to set up your laptop for a few things. Okay, but what happens if I'm going to the code and I see some architectural decisions and I don't agree maybe with some of them? I will look for ADRs, because they might be some information there that I'm missing. Maybe they try before to change something. Maybe they already implement something. They are migrating. Everything can be in these ADRs. It could be very simple, but I will give you an understanding on what is happening, but at developer level. Okay? So if we cannot summarize. So what is DDD at the end of the day? As Matthias says in one of his articles, it doesn't have rules on how to do it, and is open to new interpretations. We can have better practices. We can inverse our Conway's maneuver. But the main idea is that the developers talk and understand with domain experts. That could be the business, that could be our architects, but they will validate and help defining our domain models that represents how our software is gonna look in the future. Also, if we try to implement this in our team, as I said, this is like an organization change. It's not like you take the code and it's gonna, okay, tomorrow we are DDD like certified. No, it's more than that. We can inverse our Conway maneuver. It's not necessary that it comes like tomorrow it happens, but it could be over time, maybe new teams. Maybe you can have an inventory team, shipping team, orders team. So form diverse teams around business capabilities in order to have a product teams capable of managing the entire operation of that product. And why I say that? Because you need to adapt to change. We know what happened with COVID. COVID came, at least in Chile, it was very driven in-person business. I think most all in the world it happens, but COVID happens and everybody needed to change and go online. This was very hard for a lot of business. Most of them changed. Most of them couldn't afford going this, or they couldn't afford to escalate quickly. Most of the e-commerce, they had 1,000 requests. They usually had like 20 requests per month. Now they have 20 requests per day. So it was hard for us. We need to adapt to change. This does not mean that we really need to go from our monolith that is a big ball of mob to microservices straight away, but we need to be able to adapt to change, to start understanding what is happening and talk with the business, because maybe I want to migrate my monolith, but it's what the business needs. It's what we were talking about. The main idea is if you climb in the mountain and you can see a city, you might be able to recognize that we have factory zones, we have school zones, we have everything divided. Maybe that can happen with our application too. It's important to us to understand what is happening, how is happening, and maybe who is in charge. Maybe we have a team product that is taking the payments, or maybe we just have our backend team that is holding everything and trying to create our new API, while the front-end team is trying to help them to put that into production and to have a view from the customer. Okay, so be able to talk to each other, be able to focus on what it needs to be done. But as we say, building high-performance team, it does not depend on the team itself. It depends on the organization. It depends on everybody of us communicating. And thank you.
Thank you very much.